Hello, in this video, I will try to graph a couple of fundamental functions, fundamental graphs that are really helpful in calculus class. Okay, that's me. Let's start. Fundamental graphs. We all have to know the shapes and some properties. Okay, graph number one is the function, our best friend, y equals to x squared. Okay, what we need? We know that function is always positive because squaring the numbers, we always get positive. And this is a beautiful parabola. Okay, x and y, the coordinate plane, always arrows in one direction. And this is x squared. I can possibly put 1.11. And my scale is a little bit weird, but my labels will be good. 2 squared is 4. Okay, and possibly -1 squared is also 1. But we don't even have time to plot the points. We have to know, we have to know how to sketch the graph. Okay, and just to say, domain, it's all of the numbers. Okay, and range, set of y's, is just from 0 to positive infinity. Okay, that's what we can know. One important thing is at 0, when we will draw a tangent line, we will get to this point later. But since we are in the calculus tangent line, it's the horizontal line. That means tangent has a slope 0. Important information for later, but just in case, okay? Because at the tangent, of course, at that point, we always need the point at 0, 0, has the slope 0. Okay, graph number 1. Now, graph number 2. Graph number 2 will be another power function, x cubed. Y equals to x cubed. X cubed will take all of the values, positive and negative, because when we cube positive number, we're getting output positive. When we cube negative numbers, we're getting negative output, x and y, and this is the graph. 1 cube is 1. -1 cube is -1. Okay, and so on. Okay, now I can put some properties. The set of x, of course, is any number, domain, allowable set of x. I can cube any number, and set of y, range, output will be also any number. We can see this. And maybe the tangent line, it's also interesting at 0. If I will draw a tangent, it's a little bit, but it's still, we still consider that the curve is a line is touching the curve. This is tangent, and it's also horizontal. Tangent line at the point 0, 0 is horizontal, and respectively slope is 0. Okay, quite helpful information. Okay, another one. I think I can draw 9 graphs. Okay, that will be good motivation to the end. Okay, another function, what we can do? We can do cube root of x, actually, which is x to the 1/3. X to the power of 1/3 is the inverse function to x cubed. So we know how to draw the inverse. It's just symmetric with respect to the line y equals to x. This means instead of x cubed, we will have cube root of x. Cube root of x, something like this. Cube root can take any numbers. That means domain is all of the numbers. And cube root will also give us back any number. And cube root of any number will give us any number. And for instance, let's maybe be not just 1. We can say, for instance, 8. Cube root of 8 is 2. Cube root of -8, it will be -2. Okay, we have a couple of points. But now interesting thing and helpful in calculus, tangent line at 0. Since this is inverse function, I can switch the slide. This was horizontal tangent. Correct? That's the horizontal tangent. Now, inverse will give us a vertical tangent. Vertical tangent line, of course, at the point 0, 0. And please tell me, what is the slope of the vertical line? Of course, the vertical lines doesn't have a slope. Slope is undefined, does not exist. No slope of the vertical line. Then no, yes, no, yeah, no slope, no slope. Let's wait for more details later. Okay, but we know cube root of x. Also, since I draw the cube root of x, another graph will be cube root of x squared. That means similar functions, cube root. I mean, if that part was positive, it will stay. It will be a little bit higher because the values are squared, but it still have this. But all of the negative values will become positive with a little bit higher values. So we kind of do this. I just want to nicely meet them. That means this is the graph. Since we squaring, okay, it's supposed to be nice and symmetric. Let's do this one a little bit higher. Okay, y and x. And yeah, we can, let's just put 1. If we will put -1, -1 squared is 1, cube root of 1 is 1. It's supposed to be nice and symmetric. Let's, okay. And then 1 will also give us 1, and so on. Okay. Now, domain, we may see we can substitute any number, and range, set of y's, we only have the graph placed above the x-axis, meaning that outputs are only positive, from 0 to positive infinity, from 0 to up. Okay, and interesting thing, at the point 0, 0, because that's quite interesting thing. At any other point, we can draw a tangent line. Of course, I'm referring to the tangent. We will have no tangent line because you remember it's that sharp corner, and tangent lines supposed to nicely touch the curve and have the same direction. When I draw any line, I will never remove that sharp corner. So we do have no tangent. Yes, no tangent line at the point 0, 0. Yes, no tangent line, and then no slope. Yes, no instantaneous rate of change at that point, because we remember that. I can even say this, no instantaneous rate of change. Okay, graph number 4. I know that I'm supposed to focus just on the graphs, but I'm adding a little bit of taste of calculus. Okay, what else? We need hyperbolas. Okay, graph number 5. We just, we solved one of the question, 1 over x. 1 over x is hyperbola placed in the first quadrant and the third quadrant, because if x is positive, the output is positive. If x is negative, the output is negative. Right? And of course, for the point 1, 1 over 1, -1, -1 over -1 is -1. Okay, and then x, we may accept all of the negative numbers, and we may accept all of the positive numbers. The only number that we're not accepting is 0. And we may notice x equals to 0, that vertical line, x equals to 0, is a vertical asymptote, because the curve will never touch this line. Vertical asymptote. Okay, of course, x, or we may say x0 is not in the domain. Okay, and the outputs are the same, from negative infinity to 0, and from 0 to positive infinity, which we may also say we have a horizontal. Because for the y values, we will see, I mean, y equals to 0 is a horizontal asymptote, just in case. But just looking at the x value, since x is not in the domain, or we have vertical asymptote, if we would like to think about this hyperbolas, like in the first and the third quadrant together, we may say we have discontinuity, because the line, the vertical asymptote, is creating discontinuity. That's when we have vertical asymptotes, like no, x is not in the, no, x0 is not in the domain. I can also say no tangent line, of course. No point, no tangent, no slope, no tangent line, and no slope. But of course, 0 is not in the domain. That's mean we just, it's quite obvious, but I will just still state this. Okay, and then graph number 6, we have another hyperbola, 1 over x squared. Yeah, x squared, everything will be positive. It's still hyperbola, a little bit lower, because we remember arithmetically, if the denominator is bigger, the whole fraction is smaller. And first and the second quadrant, because everything is squared. Again, I can't really draw nicely symmetric curves. Okay, let's check. Because for 1 and for -1 will be the value 1. Okay. And now, domain, we can substitute any numbers, but not 0, the same thing. And outputs actually are not 0, but all positive numbers. Okay? X is domain, Y is range. And if I will be consistent, the same thing, the line x equals to 0 is a vertical asymptote. Since the number is not in the domain, we have no tangent. Yeah, we have discontinuity, no tangent at 0, because it's not in the domain. No point in the domain, no tangent, no slope. No instantaneous rate of change. Okay, oh, I didn't put the number 5, that's number 6, number 6. Oh, what else? What else? Oh, number 7, absolute value of x. Also a typical graph that we have to know how to draw it. And we know that is positive and negative part. Because normally what we will do, if we have to draw the absolute value of any function, we can first focus on inside function. And that means the inside function is just y equals to x, which is that line. And taking the absolute value, everything what was positive will stay, okay? But everything what was negative will become positive. Okay, that's the reason that we have this, based on the definition. Oh, of course, I erase everything. Okay, or if we would like to get the definition, that's also helpful. Actually, it's the same way, but absolute value of x, it is x, we just ignoring absolute value if x is positive. Or if x is negative, absolute value of negative number, I can't just put x, I have to make it positive. And that means x and negative x. This is line x, this is line negative x, piecewise defined function. Okay, domain, all of the numbers. Range from 0, actually including 0 to positive infinity. Okay. And since, let's be consistent, tangent line at 0. Now 0 is in the domain. We know that when we have this sharp corner, it's not possible to draw a line that will smoothly like get almost like have the same direction as the curve. That means at the point 0, 0, which is in the domain, is no tangent. Yeah? No tangent line. No tangent, no slope at that point. Yeah? No tangent line does not exist. Okay. And what else? What else I have? Okay, number 8 will be square root of x. Okay? Square root of x, x and y. Its square root only take positive numbers and looks like this. Yeah, it's kind of half of the parabola. We know the inverse. Okay, and for 1 is 1. For 4, for instance, square root of 4 is 2, and so on. Okay, that means domain, it's all of the positive numbers, and range, also square root of the positive number is a positive number. First quadrant, perfect. And to be consistent, at 0, 0, 0, 0, 0 is in the domain. But we will also consider this as a like sharp end. It's an end point, and the same, we will be not able to draw a tangent line. Yeah, because it's the sharp corner. That means we will have no tangent. Yes, no tangent line at 0. Because we don't know, maybe it's a vertical, maybe it's no, we will not, yes, we will not draw it. No tangent line at the end point of this domain, at the point 0, 0. And no, I just don't, no, I don't want to give you wrong impression. No tangent. Okay, no tangent line, no slope, no instantaneous rate of change. Let me just, okay, and then number 9. Number 9, I usually ask for this graph, square root of 1 minus x squared. It will be helpful. Probably we don't know exactly what is the shape, but if I will take this equation first, and let's maybe rearrange. Let's square both sides. If I will square the left-hand side, and if I will square the right-hand side, I will get this. Of course, thinking about the domain, I want this expression to be positive, and the expression under the, let's actually put domain, and we may solve this inequality. And at this point, we will drop the inequality notation. We know that one of the 0 is actually plus -1, one of the 0 is +1, and we will test the interval. When I substitute 2, I will get negative number. Then when I substitute 0, positive, 1 times 1, and -2, negative number, because -2 will give us +3 and -1, positive. Negative number when I multiply. Okay, that means this expression is greater or equals to 0 if x is from that interval. That means domain is only x belongs from -1 to 1. Okay. So now arithmetically, algebraically, we okay to simplify this. Okay, and now let's actually add x squared to both sides. And now we probably recognize this equation. X squared plus y squared equals to 0 is basically a circle. Oh, almost perfect. You can never get a perfect circle, right? Okay, 1, -1, 1. The center is 0, 0, the radius is 1. Okay, but now let's be careful. If we will, this is the circle, definitely. And we can see the domain match from -1 to +1. But now, if I will take this equation and I will ask you to solve for y, then we will subtract x squared from both sides, and we will take the square root. But taking the square root of both sides, we will end up with positive and negative. Positive is that part, the upper semicircle. Negative, yeah, negative let's maybe will be the lower part. And since we don't have negative, because I ask for the graph of the positive square root of 1 minus x squared, we will only have the positive part. Okay, that means this is the graph that I gave you at the beginning. Semicircle, positive part. Okay, we have the domain. And also, based on the graph, we can see range are from 0 to 1, only positive, or from 0 to 1, not infinity. The circular is, okay, that's one. And if we like talking about the tangent line, we may have tangent at every single point except the endpoints. Because again, the endpoints are considered as a sharp ends and no tangent. Okay? No tangent. If we have semicircle, of course. Yes, if we have semicircle, no tangent at point 1, 0 and the point -1, 0. Okay? Because they are endpoints, sharp corners. We will not get tangent line, smooth vertical, or no. If we have the entire circle, yes, we can have a tangent. And the tangent, of course, will be, if we will have, let me just see, if we will have this, tangent will be vertical. That's we will have tangent, however, but the slope will be vertical. I mean position of the tangent will be vertical, and for the vertical, we can say, for the vertical lines, we can say no slope. That means no slopes actually is the general statement. But in our case, it's the same, no tangent, no slope. Vertical tangent, also no slope. Okay, that's the graphs. We also have a couple of graphs, I mean 4. Do I have one page? Yes, I have one page. I mean, I consider these algebraic functions that I gave you, the 9 graphs, as a fundamental, but also, if I'm listing them, I would like you to know exponential function, let's say natural, e to the x, natural log of x, and maybe sine of x, cosine of x, and tangent of x. Okay, I promise that's the last one. I can draw e to the x, exponential, growing extremely fast. Right? Logarithmic function, it's the inverse to exponential. Looks like this. I just put two graphs in one xy plane, and they are definitely symmetric with respect to the line y equals to x. Okay, and then sine and cosine, we know, we practice this. Sine is like this. Sine curve, at least one period, 0, pi, 2 pi, and so on. Range is between 1 and -1. Quarters, okay, and then cosine. Oh, I don't have, cosine actually has maximum at 0. Okay, that's pi over 2, that's pi, that's 3 pi over 2, and this will be 2 pi. That means this is one period. We did talk about. Also, the range is from 1 to -1, from -1 to 1. And tangent, oh, please, yes, I have one more slide. Tangent, not natural log. Tangent is also helpful because we will have some limits, some derivatives. Tangent is not defined wherever cosine is 0, because tangent is sine over cosine. That's tangent. That's tangent. That's tangent. This is 0. This is pi over 2. Negative pi over 2. And every pi, the situation repeats. Pi. Okay. 3 pi over 2 negative 3 pi over 2, and so on, negative pi. And we can see pi over 2, 3 pi over 2, let's come back, pi over 2, 3 pi over 2, cosine is 0, and we cannot divide by 0. Okay, that's it. Please make sure that we know the graphs. I'm just thinking about inverse tangent. Oh, wow, then you will be excellent. Okay. Inverse tangent, we restrict the domain, and we just taking this middle part from negative pi over 2 to positive pi over 2, and just, okay. Looks a little bit like cube root of x, right? But no, it's different. No vertical tangent at 0, just this curve. And cube root doesn't have a vertical, I mean horizontal asymptote. So please remember, arctangent of x, inverse tangent, is domain is all of the real numbers, and range, which is set of y's, is between negative pi over 2 to positive pi over 2, because that was the restriction of the domain to create an inverse. Okay, that's when we do have 14, right? This is still, we have 14 graphs instead of the 9. 9 plus the pre-calculus, the transcendental function. Okay, thank you. Enjoy them and be confident with them. Thank you.